Welcome back to my channel. Now we will talk about no less interesting inventions of the time when Germany was under the rule of the Nazis. During this time, they did a lot of new things in various fields, which changed the development of technology very much. They created better versions of rockets and bombs that could be aimed at a specific target. The Wasserfall surface-to-air missile, history context. The Wasserfall was a groundbreaking surface-to-air guided missile system designed to intercept high-altitude Allied bombers. It was a part of the German military's efforts to counter the overwhelming air superiority of the Allied forces. The Battle of Britain in 1942 created a fighter shortage due to Allied air superiority, leading to a lack of planes capable of countering armored bombers and larger escort squads, caused by engine, steel, and aviation fuel deficits. Air defense aims to neutralize attackers or force evasion to protect targets. To address these issues, the development of missiles like Wasserfall emerged as a solution, drawing on advancements in V-weapons, torpedoes, and rocket engines by the German Reich. Developed by Nazi Germany, this surface-to-air missile aimed to counter Allied air attacks. The project began in the late stages of the war and represented a significant leap in rocketry. Technical characteristics. This rocket boasted impressive specifications. With a length of approximately 5.5 meters and a diameter of around 54 centimeters, it was propelled by a dual-thrust motor, reaching speeds of nearly 770 meters per second. The Wasserfall used a liquid propulsion system that allowed it to climb to an altitude of about 30,000 feet and was one of the first surface-to-air missiles. The missile was notable for its propulsion system, which allowed it to launch quickly and intercept enemy aircraft at high speeds. What made the Wasserfall stand out was its propulsion system. Unlike conventional artillery, this anti-aircraft missile harnessed rocket power for its trajectory, offering enhanced speed and maneuverability. Its rocket-powered design made it a formidable threat to incoming aircraft. Radio command guidance. This missile's guidance system was cutting-edge for its time. It utilized radio command guidance, enabling operators to guide the missile toward its target. Operators on the ground controlled the missile's flight trajectory, adjusting its path remotely to intercept enemy aircraft. Combat usage. Until February 1945, Pienmann's work ceased and the base was evacuated in central Germany. At least 44 missiles were launched, primarily using visual guidance. Around 12 launches were successful as per some sources, while others claim 25 rockets were fired, with 15 successes. Plans aimed for mass production of 5,000 missiles monthly to cover German cities with over 100,000 residents. Despite readiness for serial production by 1945, the war's end disrupted these plans. Post-war impact. Even though the project never happened, it was really important for making SAM technology better around the world. You can see its influence in later SAMs like the Nike Hercules. This missile was used by the United States and NATO during the Cold War to defend against airplanes from far away. Fritz-X guided bomb, history context. The Fritz-X, also known as the FX-1400, emerged during World War II as one of the first precision-guided munitions in history. Developed by the German Luftwaffe, this guided bomb was a game-changer in aerial warfare tactics. It was designed to be dropped from aircraft, capable of striking targets with unmatched precision compared to conventional bombs of that era. Technical characteristics. The Fritz-X was a free-fall, armor-piercing bomb weighing around 3,450 pounds, 1,560 kilograms, with a length of approximately 10 feet, 3 meters. Its aerodynamic design, featuring 4 fins at the rear, enabled stable flight and accurate targeting. Guidance system. One of the most remarkable features of the Fritz-X was its guidance system, setting it apart from other ordnance of its time. It utilized a radio control system that allowed the operator in the aircraft to guide the bomb by radio signals. The bombardier would visually track the bomb and make manual adjustments to ensure it hit the intended target. This technology was revolutionary for the era and laid the groundwork for modern guided missile systems. Combat usage. The Fritz-X received its first operational use in 1943 in the Mediterranean theater, where it was used against Allied ships. One of the most notable uses of the Fritz-X was the sinking of the Italian battleship Roma, which caused considerable casualties and destruction, demonstrating its effectiveness against heavily armored ships. Historical legacy. The legacy of the Fritz-X is significant in the evolution of military technology. It was a precursor to modern precision-guided munitions and paved the way for advancements in guided missile systems. Its impact on warfare strategies influenced post-war developments, inspiring further research and development in guided weaponry. Ruhrstahl X-4 Air-to-Air Guided Missile, History Context. The X-4 is an air-to-air missile developed in Germany during World War II, designed to enhance the capabilities of the Luftwaffe. Prompted by massive Allied air raids in 1943, Germany began the X-4 guided air-to-air missile project in 1943 in an effort to create a long-range standoff weapon. Flight tests commenced in August 1944, but challenges in guidance led to a transition to multi-seat planes. Production, impacted by Allied bombing, may have reached around 1,000 X-4s, yet official delivery never occurred. Technical characteristics. X-4, a cutting-edge missile of its time, weighed approximately 580 pounds, 263 kilograms, and measured 10.5 feet, 3.2 meters, in length. Propelled by a liquid-fueled rocket motor, it reached speeds exceeding 1,150 kilometers per hour, 710 miles per hour. Its distinctive four wings provided stability during flight. The X-4, powered by a BMW rocket engine, traveled at 1,150 kilometers per hour, 710 miles per hour, between 1.5 and 4 kilometers, 0.92.5 miles. This wire-guided missile with a range of 3.5 kilometers allowed fighters to attack bombers beyond the reach of defensive weapons. The X-4 was developed for the Me-262, but was later used on multi-seat aircraft such as the Yonkers Ju-88, similar to the successful Fritz-X anti-ship bomb. Guidance system. What set X-4 apart was its guidance system. This missile utilized a wire guidance mechanism, where the operator controlled the missile remotely via a trailing wire. This allowed for real-time adjustments, making it one of the earliest examples of guided missile technology. Combat usage. The X-4 was never used in combat, and though test flights occurred with it mounted on the Me-262, it was never fired, likely for aerodynamic tests. Launched from Focke-Wulf 190s and Yonkers Ju-88s, it never targeted live objects. The later X-4 missile and challenging wartime conditions restricted its combat impact. Historical legacy. The X-4 guided missile left a lasting legacy as the world's first guided air-to-air missile. Although it never found combat use, the technological advances and lessons learned during its development laid the foundation for future guided missile systems. In particular, the X-4's wire guidance system influenced subsequent generations of missiles, contributing to the development of modern air-to-air weapons. The history of these Nazi-era inventions is truly fascinating, but it is important to remember the context in which they were created. It is important to realize that scientific and technological advances can be both good and bad. It can help us move forward by mastering new technologies, but it can also be used to our detriment, bringing great suffering and destruction to humanity. The Wasserfall surface-to-air missile, featuring advanced propulsion and radio command guidance, marked a significant leap in World War II rocketry. The Fritz-X guided bomb demonstrated a revolutionary approach to air warfare with its precision guidance system, which laid the foundation for modern guided missile systems, defining post-war developments. The world's first air-to-air guided missile, the X-4, despite never having participated in combat, left an indelible legacy. Its wire guidance mechanism influenced subsequent generations of missiles and contributed to the development of modern air-to-air weapons. All of these technologies, rooted in dark history, have had a significant impact on military technology. Exploring how old technologies affected the military is important. We need to see that these past developments not only changed things back then but still affect what happens now and what might happen later. Understanding the errors of past military history teaches us the importance of being cautious and ethical in developing new military technology. Give a like, share with your friends and subscribe to the newsletter to learn more about history and technology.